Cyber Gibbons.
Okay, I'm doing two talks today. This is not the Bitfi one, this is the Z-Shave one. This one, the disclosure that went down with Scilabs and Sigma Designs was pretty bad, but since Bitfi's happened, disclosure can't get any worse. So we've kind of cut that bit out of this particular talk. Now I don't know if you know much about Z-Wave. Now what Z-Wave is RF communication protocol that's used for home automation mainly. So it's connecting things like light bulbs, light switches, blinds, sprinklers, locks, cameras, through to a hub, which will then connect through to the internet. So it runs on 868 megahertz in EU, maybe 915 in the US. There's not much to the RF side of things. There's no frequency hopping, there's nothing fancy there. Now, some of the sensors that it uses are pretty boring, things like flood sensors. So all this does is sits underneath your sink, and if it starts leaking, it will send a signal through, you'll get an alert that your house is flooding. I've got another flood sensor here. They're pretty basic things, and there's not much security impact you're going to get from one of these being compromised. But there's more advanced things. This is the Ring burglar alarm. Now, all of the individual components in this are actually Z-Wave devices that connect through to the panel, which then connects through to the internet. But kind of more interestingly to me is locks. Now, locks are also connected via Z-Wave, and that's what I'm going to do the demo with today. Now, there's not actually any technical issues with the lock. This is a protocol issue with Z-Wave, not a problem with this lock. So just ignore the manufacturer on it. Now, Z-Wave's got 3 different levels of security. It started off with no security at all. So the commands were just sent in the clear from one end to the other, which meant that someone could walk up to your house and they could turn your lights on, they could turn your heating on, they could open your locks. That's obviously not good. So what they did was they introduced S0 security. And S0 security introduces encryption and pairing. So only devices that are paired to your hub can communicate. The problem with that was it was found that you could intercept the pairing process. So SensePost, a pen testing firm, found out in 2013 that you could sniff the pairing process, obtain the key, and then command the devices. So what the company, the Z-Wave Alliance that's behind Z-Wave, did was introduce S2. And S2 uses Diffie-Hellman and authentication, so that even if you're there at the time of pairing, you can't intercept the keys. What I'm going to be talking about is how we can downgrade the security from S2 to S0. So we undo all of those advantages they've put in. I'm going to start talking about how S0 security works, so you get an idea of the vulnerabilities and why we'd want to downgrade to S0. Now, the network's got a 16-byte encryption key. Now, it's really quite interesting, this. They actually generate it using a true random number generator. So every single Z-Wave device, this little controller here, has a proper hardware random number generator inside of it, and it's got to use that to generate the keys. If I hard reset this device, it generates a new key. Now that's quite good. It's quite rare to see that. Poor, weak key generation, something we see a lot in IoT devices. Now what it does is it then derives an encryption key for encrypting the data and an authentication key for authenticating the data. It does that simply by encrypting 16 bytes of 55 and 16 bytes of AA using the network key. So you've got 2 different keys. It then encrypts the message, and it uses AES OFB. Now this isn't a perfect mode of encryption. It doesn't inherently have authentication around it. If you reuse the initialization vector on it as well, it's open to a number of weaknesses, but they use it securely. And then, really importantly, they wrap that with authentication. Now, nearly all of the time with home automation, you don't really care about privacy and secrecy of your data. If you see someone walking up to their house and their door unlocks and you sniff a packet at that moment in time, you know that they're unlocking the door. It doesn't matter if that's encrypted. If you can replay that packet, if you can modify that packet, that's something bad's going to happen. It's the authentication of that packet that's important, making sure it came from a genuine party. So they use AES CBC MAC, which is a kind of construction using AES to create a keyed message authentication code. And again, that's secure. So the encryption's using AES OFB, which is secure. The authentication's using AES CMAC, which is secure. The key generation's using a true random number generator. It's secure. You can't replay. Now what it does is the IV, it sends half of the IV from one end to the other, and then the other end uses the other half of the IV, which means that packets have to be fresh. You can't just spoof packets, you can't replay packets. So that's secure as well. But the problem is with the key exchange. They haven't used a widely accepted and secure way of exchanging the keys between 2 devices. Now you'll notice this is a series of different Z-Wave devices. They don't have a user interface on them. It's a flood sensor. There's no way for me to type the key into this device. It's not like a phone, it's not like a computer where if we join a Wi-Fi network, we can type the key in. There's no way to do that. So they've got to exchange the keys somehow between the device and the controller. Now the way they do that to move KN, the network key, from one end to the other is they encrypt it with a temporary key so that it gets into the device. Now the temporary key that they use is 16 bytes of all zeros. So I don't know if any of you have worked with Zigbee before. Zigbee does a similar thing, and what they do, their network key is Zigbee Alliance 09, because the standard was published in 2009. That was secret. Again, this was held secret for a while, but you can reverse engineer different controllers, different firmwares, and get this key. So that introduces a problem. As an attacker, if I can sniff that key going from one end to the other, I can recover it. So if you're there at the time of pairing, you've got that key. Now, I'm going to try and do an actual demo here, which may or may not work. These screenshots are just in case it doesn't. What we have here is a piece of software that's acting as the controller, running on my laptop. So this laptop's the controller, and if we go to this, what we have here is a sniffer, and what this is doing is it's showing us the Z-Wave traffic as it goes backwards and forwards. If I can find the mouse pointer, I'm just going to restart this so the screen's nice and clear. Clear screen there, and then if we jump through to... That's not working, is it? Jump through to the controller. What I'm going to do is very simply, I'm going to press add. So this is like pressing a button, authorizing the controller to add a device. Then on this Z-Wave device here, I'm going to press 3 buttons. You can see at the bottom there's a load of traffic going on, and it's now paired with this controller. So now this is communicating with the controller here. It's exchanged those S0 keys, but we can decrypt them. And I'll show you how easy that is to do. I'm going to just jump back through to the sniffer here, scroll back up to the top. Now you see right up at the top here, we get what says security message encapsulation there. And it says that it's trying to decrypt it there. There's no decrypted content. So all we have to do is press decrypt. The key of all zeros is automatically populated because the tool already knows this is bad. From that point, it then gives us the network key. So it's decrypted that network key. We can just copy and paste that, go to the next encrypted packet, which won't decrypt, press decrypt, paste the key that we've just sniffed in, and it's now decrypted that data. So it's really, really simple. So even tools made by Scilabs will do this decryption. It's a known issue. Now PowerPoint doesn't want to come back. I can't actually work computers. There we go, okay. There's other problems. Now, if you come along and you press the button on the controller, and you press the button on a genuine device, you'll pair that genuine device. But if someone outside your house comes along at that moment in time, and presses a button before you press the button, they'll join their device to your network. So it's like a race condition there. Whoever pairs first will get paired with that controller. There's no authentication of the node you're joining, so you don't know if the node that's joining is a genuine node. The other problem is that if you've got a door lock, a cat flap, a light bulb, heating and sprinklers all on your Z-Wave network, with S0, all of those have exactly the same key. So if you sniff any of those pairings, you've got the key to unlock the door. If you steal someone's sprinklers from their garden, the unprotected zone, you've got access to the keys. So the problem is, if you're in range at the time of inclusion, you can obtain the keys. So that's a bit of a problem. You'd be unhappy if that was possible with your Wi-Fi network. The devices aren't authenticated, and there's a single network-wide key. Now, they recognised these as issues, so what they did was they introduced S2 security. We don't know what happened to S1. I asked them. It doesn't seem to exist. To be honest, I don't really care about S2. I'm not breaking S2 security. this is the thing. I'm downgrading S2 to S0, so it's completely outside of the S2 security. But it's probably worth explaining it. Now, what they said here was S2 also completely removes the risk of devices being hacked whilst they are included in the network. Now, this really gets me going when people say completely removes the risk. If they use the word unhackable as well, it's a bit of a trigger, to be honest. So we were interested in this. Completely removes the risk. So the way it does this is it uses elliptic curve Diffie-Hellman to exchange the keys. So that could still be vulnerable to an active man-in-the-middle attack. You could sit there with a device that performs Diffie-Hellman on one side and the other side, and you'd be able to intercept those. But what it also does is it uses what's called a device-specific key. So you have to type in 4 or 5 digits of the key into the controller, and that authenticates the other device. It shows the rest of the key as well. And instead of using one key, it's got 3 different layers of keys. You've got access control, which is used for locks. You've got authenticated, which is used for things you care about, and unauthenticated, things like your cat flap. So comparing them, you can see that S0 uses AES OFB, S2's moved to AES CCM, so it's got integrated authentication. So they can't make any mistakes there. The number of keys, it's gone from single to multiple, key exchange, symmetric and sniffable to Diffie-Hellman, and they've actually authenticated the connection, so they fixed a lot of problems. Now, there might be issues with S2, I don't know. I'm not a cryptographer. I like cryptography, but I couldn't see any obvious issues. So we started looking at the specifications and the standards. Now, one thing we quickly realised was that the Z-Wave ecosystem is really closed. If you sell a Z-Wave device on the market, it's got to use one of these little modules. So this is a module made by Scilabs. There's supposedly ones that are made by Mitsumi, but we can't buy them, we can't find any in any product, so I don't think they genuinely exist. So that module's got to be in there. You can customize certain aspects of the firmware in there, but the actual RF stack is a standard Z-Wave thing. You can just put an application on there. Now, if you sell that product, it's got to be certified by the Z-Wave Alliance. It's got to go through a period of testing. And a really big thing about this is they say that any 2 devices have got to interoperate. So what that means is if you've got an S0 controller, one that doesn't support S2, and an S2 lock, they've got to work together. If you've got an S2 controller and an S0 lock, they have to work together. Now, when you say backwards compatibility, again, that just shouts downgrade attack to me. It says there's going to be a way to work backwards from this. They have this brilliant page here, which you can search for any device, and you can see if it's been certified. You can see at the top there it says there are over 2,400 interoperable Z-Wave products. They really go on about this interoperability. The thing is, we can downgrade, and it works both ways. I've got a few tools here, and I'll explain why I'm using them. At the top there, we have a Sigma Labs product that acts as a controller. The reason we're using that is it's the only thing we could find that supported S2 security. There were no hubs on the UK market at the time that supported S2. This is another controller that technically supports S2, but we can't get it working. The little black box is called the sniffer, and this is just a ZigBee sniffer. It was providing the data to that Wireshark-like application. There are free tools that do sniff ZigBee, but they don't do the decryption. They don't deal with all of the different speeds and all of the different protocol variations. So it costs £700 to buy a development kit, and you get the only 2 useful bits for a pen tester's perspective are these 2 little dongles. So not particularly good value. That gives us access to the sniffer tool, which is the decryption like Wireshark. It's pretty good, to be honest. And it gives us access to the PC controller, so that's just acting like a hub, but on a laptop. Now, the other tool we're using is called a Yardstick 1. So that's another little USB dongle there. It has a TI chip on it that's an RF system on chip. It's got a firmware on it called RFCat, and that allows it to be commanded with Python. It makes working with RF quite easy. It's not as powerful as an SDR, but it works differently. And the reason we use it for a lot of these attacks is it has half a watt of power output. Now, an SDR's got maybe 10 milliwatts tops, which makes practical real-world attacks quite difficult to carry out. Half a watt, if I set that jamming on 868 megahertz in my house, causes widespread disruption in the area. People's burglar alarms stop working, they can't unlock their cars. It's got enough power to cause problems. Now, the other thing I'm using is a Yale lock. It's a Fairly standard lock to fit to UK doors. I don't think it would work anywhere else in the world really due to the form factor. It's got RFID, it's got Bluetooth, it's got Z-Wave. The Z-Wave's done via a small module, which is mounted in the top of the lock up here, so it's just a little blue module. It's got that device-specific key I said on it. You can change that for other devices and use other protocols. So it's not an issue with the lock, it's with Z-Wave, so it's not really a problem with Yale. So if we look at how an S0 node pairs, what happens is the user comes along and they press add node on the controller. You saw me press the add button. Then what we do is we press a button on the device. So with this one, it's a triple click, and then it decides it's going to join a network. It sends out what's called its node info. It shouts, I'm this kind of device, I support these kind of functions. An acknowledge goes back, the device gets brought into the network, and then you get the key exchange. So that bit down there, the security scheme get, security scheme report, is where that key is exchanged. That's how S0 works. S2, well, it starts out pretty much the same. It does a node info, it gets assigned to the network, finds nodes in range, and then the actual key exchange is different. It's called a KX. Now, up until that point, those two communications are almost identical. Exactly the same packets are going backwards and forwards. The only two things that are actually different are these node infos that are being sent from the device back to the controller. And if we look at that in the sniffer, what it turns out is that the only thing that's different is at the bottom there. You can see how it says 9F, Command Class Security 2. That means this device supports S2 security. The one above it, Command Class Security, means that it supports S0. Now, that packet's not encrypted. That packet's not authenticated, which means we can tamper with it. So on the left-hand side there, we've got the normal process, and on the right-hand side, I've got what we call the modified timing attack. So essentially, this would happen if the user presses the button on the device rather than the controller first. So it sends out its node info, we grab it, we rebroadcast it as an attacker, but modified. We drop the support for S2 security, so we just remove that entirely. The controller, you then press the button on it, it adds that node, and in theory, you should pair that device with S0 run S2 security. Just a close-up of how that works. Now, this sounds ridiculous, but the only reason we uncovered this was we found there were certain devices, when you put the battery into them first, it broadcasts the node info, so you don't have to press the button. So you could just put the battery into a device when you're pairing it, it would broadcast the node info, and as an attacker, you can grab that packet and then retransmit it. The other one that we were working on was a reactive jamming attack. So this is a bit different here. As the node info is sent, we'd then jam it halfway through that packet. We'd receive the part of the packet we need at the beginning. We'd then start jamming it so the controller didn't receive it. We only have to flip one bit in the packet because it's got a CRC checksum on the end of it. Now, that's probably possible. The way we're using this RFCAT device, it has to receive an entire packet before the computer's aware of the data. So there's no way to easily reactively jam. So we haven't actually got this one working, but it's conceptually possible. Now, you think, why do we actually have to receive this data? Why do we have to know what that data is to retransmit it? And the reason is this is a device broadcasting its first node info. Now, you'll see its source there. Its address is 0, and it's sending it to 255. Like with most protocols, 255 is the broadcast address. So it's sending it from an unassigned address to a broadcast address shouting, I'm here, pair me into your network. The home ID is a unique identifier for a device unpaired or your network. Now it's got a random home ID when it's first being paired. It's randomly generated. You can see here F1 starting there. As it gets brought into the network, it changes to C1, which is my genuine home ID. So we have to grab that home ID to then retransmit the node info packet. Otherwise the attack won't work. Now I'm going to demo this. It may or may not work. Let's see how it goes. Right. I've got a video if it doesn't work anyway. So what we have here is the Z-Wave controller. At the moment, it has the S0 device, and what I'm going to do is I'm going to pair the lock as an S2 node first. So this should work. I press add, triple click the button on the back. Then this should prompt me, I want to add it as an S2 device. It will ask me for the device specific key, which is 2102. No, what is it? I knew I'd forget that. 20102. And if you don't get this done quickly enough, it times out and it adds as no security. So we'll see if this works. If I missed it. No, it's going through. So you can see there, up at the top, it's a bit small, it's showing as S2, so it's been paired as an S2 device. We can now command that lock. So we go through to the command classes, come down here to the supported command classes of the device. And what have we got? Door lock, door operation set, door unsecured, and if I press send, it's already unlocked, so let's try locking it. So you can see how we've got control of the lock through the controller. Now what we're going to do is we're going to remove that node. So to remove a node, you've got to actively press it. We haven't found a way of de-authenticating nodes or breaking them out of the network yet. So that's now removed from the network. Now what I'm going to do is I'm going to listen for that node info as it gets sent, and I'm going to retransmit it as an S0 device. So if we just restart the sniffer, get ready to press add. So what I'm going to do is I'm going to do it in the wrong order. The actual script's running on this laptop. There's nothing hidden, you can come and see it later on. I'm not doing any trickery or anything like that. So it's listening now. I triple click, wait for it to send a broadcast packet, press add. That's just resent it, and you should see in a second if it works. You can see at the top there, S0 secure keypad lock. So we downgraded that pairing. You'd notice I didn't have to enter the device-specific key, I didn't have to answer any of those questions, but I haven't done anything differently. Now the thing is, the lock's not mentioned this. The lock's not got a red LED on it saying, I've paired with S0 security, run S2. It's got one LED and a buzzer on it, that's it. There's no user interface, so it's really difficult for them to do that. We can go through to here, and because we've got that security message encapsulation, we can press decrypt, put the keys in of all zero. Oh, what happened there? Oh, I went too soon. So if we go to this one here, this will decrypt with all zeros. Yeah, it's already done it with all zeros. So we've got the network here again by sniffing it. So that's what that attack's allowed us to do. Right, we'll skip over the video because it worked. So what's the impact of this? Now, this is kind of where it gets interesting to me. The attack's quite simple, you'll admit. There's no cryptography involved there. All I'm doing is just sending a packet that's modified. Now, one of the problems is, once that S0 key's been compromised, I've got the S0 key for all of the devices in your house. Now, I looked at a poll on a forum for a home automation piece of software, and it seems that most people who put Z-Wave in their house have got more than 30 devices. Now, if you want to repair those devices and change the key on your network, for nearly all of them, you've got to manually go to that device and press a button on them. Now, that can be a bit of a problem. You know, if you're having to climb up ladders, remove switches from your walls, dig things up, you know, it's going to be a problem. So changing those keys, it's not supported. The thing is, people have said, why didn't you just downgrade to no security rather than downgrade to S0 security? If we look at an existing network, so we've got an S0 door lock, an S0 light bulb, and some sprinklers on no security. If I walk up to that house, all I can do is access the sprinklers. That's it, nothing else. Now, if I bring a new device in, and it pairs as S2, all I can get access to still is those sprinklers. I can't get the key from that. If I downgrade that to no security, all I have access to is the heating and the sprinklers. But if I downgrade it to S0 security, I have access to the entire network. It would only be the S2 devices I don't have access to. So that's why we went for that downgrade from S2 to S0. So what about the likelihood? Now, I don't know why this got into the press big time. There were loads of articles, you know, the Register, I can't remember all of them. It got into home automation magazines, things like that. And the coverage wasn't necessarily proportional to the risk. The Register blew it out of all proportion, whereas some home automation magazines took it completely the other way, saying it wasn't really an attack. So the first thing that Scilab said to me was the evildoer would have to be 30 to 40 meters away and listening. Now the thing is that they state openly that the range of Z-Wave is 100 meters. Now, I don't know about you, but if the attack, when you're carrying it out, you can't say that the range is 100 meters when it works, but when someone's trying to attack it, it drops down to 30 or 40 meters. The thing is, as an attacker, we don't have to play by the rules. This little module here has probably got 10 milliwatts of output power. If I can use a directional antenna and 500 milliwatts of power, I might be able to do worse things than a standard module. So we found that the radius of attack was definitely 10 meters. There used to be a thing called low power inclusion mode. So when we were pairing this device into our network, it would transmit with low power, but that's been deprecated. So they transmit with full power. So we managed to do it 10 meters outside a house. Now we'd probably manage to extend that to 40 meters. I don't know. We could possibly get that out to 100 meters. It's still a local attack though. What's important, it isn't a remote attack. There's no way for me to do this from the other side of the world. I have to be local to it. But really importantly, it's not so small that we wouldn't be able to do it without entering someone's property. So they're trying to downplay this range aspect of it. The next one was, they said an attacker would need to know the precise 20 millisecond window when you were doing the pairing. I just don't get this. Now this got repeated again and again by someone high up in the company. Now the thing is, it doesn't really matter. If the pairing's really short and happens 3 times and we're there for that duration of time, we'll hear it. We'll be able to uncover it. If it takes longer, we'll still uncover it. In reality, if we're there for a shorter period of time, the pairing actually takes longer, there's less of a chance of us being able to successfully capture a pairing. So the duration of it doesn't matter. What matters is the frequency. You don't pair nodes into your network that often. So if you're not there for a pairing, you're not going to get the key. So I don't know why they said that the duration matters. The next one was, this one's a really common one, specialist equipment's required. I'm sure some of you use SDRs, things like that. They've said specialist equipment's required. Well, it's a yardstick one, which now you can buy off Amazon for just under £120 and turns up on your door the next day. Don't laugh at my code, it's really bad. But the code, it's maybe 90 lines of Python. That's it. I mean, it doesn't work in all situations, but it's a script. Anyone can run it. Plug the device into a laptop, run the script. The next one was attacker must be in range at the time of the attack. Now we get this one again and again. I don't know why, but with physical attacks, people assume you have to be stood outside the house. Now this was awful. So we blogged about using the yardstick one to disable and jam burglar alarms. There's a lot of consumer burglar alarms that are vulnerable to that. And I don't know how many of you know about the Daily Mail. It's not exactly the most balanced newspaper, but essentially they took our story, went and bought a yardstick one off Amazon, and then made a guy in a hoodie stand outside someone's house with a laptop. They weren't focusing on the burglar alarm being vulnerable, they were focusing on the fact that Amazon was selling this tool. The comments were all just like, must pull these off the market immediately. It got worse as well. Now, we do a lot of work with cars, and that's a HackRF on there. And they wrote another article about the HackRF and how awful it was. Now, that HackRF I don't think is even plugged in. And I just find this idea of walking around with a laptop doing this bizarre. It's a Raspberry Pi with a yardstick one plugged into it with a battery pack inside the box. That's all you need for the attack. You could put that behind someone's hedge, walk away. You don't have to be sat outside the person's house in a hoodie looking shady as fuck. So, the marketing versus reality now. This is kind of where what we realised was Z-Wave were trying to pitch this S2 solution as required. They were trying to say S2 security is needed because you secure that inclusion process. You can't get the keys. That elevates them above Zigbee, where Zigbee Alliance 09 allows you to grab the keys. So what they said was the Alliance Board of Directors voted to make the implementation of the new Security S2 standard framework mandatory for all products from, well, April 2017. So they said it's got to be mandatory. It's in all products. On the date, on the 2nd of April, they said that from that date, it's a strict and uniform adoption of a new security protocol for all devices. And, well, what it turns out is that's so far removed from reality. This is a lock module. I've not picked this company for any particular reason, off the certification site. And you can see the certification date there is the end of April of this year, not 2017, this year. Now we go drill into that, and we can see support security S2. No. Now, that's obviously quite bad. HomeSeer is a common piece of home automation software that deals with Z-Wave. Now you can see here, they say any new device released after April the 2nd, 2017 must support S2. There are exceptions. Code space in the 500 series Z-Wave chip is limited. So what they're saying is there's technical limitations that make it difficult to support S2. So they're saying it must, that the capitals there are their capitals. That must is theirs. But then they say immediately after there's exceptions. So what we did, we looked at all of those devices, and between these two periods we found that only 48 out of 180 support S2 security. So, mandatory. They have a really, really strange definition of mandatory. It's so far removed from the truth. But it gets weirder. We reported this vulnerability to Scilabs. Scilabs bought Sigma Design to make the Z-Wave modules. It only happened maybe 2 months before we reported the issue. We immediately got an email back from a PR company, not a security team. Now, I don't know how many of you do vulnerability disclosure, but if you get an email from someone who's a PR company, generally disclosure is not going to go particularly smoothly. It kind of came out eventually via a very dodgy press release that they actually knew about this attack. So they pointed me to this piece of documentation here, which mentions explicitly an S0 downgrade attack. Now, this documentation wasn't open, it wasn't public before they released it. And it says, if an S2 node has been securely bootstrapped, blah, 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 if it's been brought in as S2, you've got to put a warning message there for the user. So a warning message has got to show. The problem is they don't specify how that warning message should show. This has got an LED and a buzzer. That controller has got an LED and no buzzer. It's quite difficult to warn a user. We did find out that the HomeSeer software does actually support S2 security. It took a bit of tweaking to do. This is how it warns the user. It says adding using S0 security. That's it. That line there out of this wall of text. So that's the only warning a user gets, it's been downgraded. Now, that's beta software, so I don't know if they've improved on that or there's a better way of doing it. The press got interested, and what Scilabs did was they released a penetration test report. Now, I've got a lot of respect for SensePost. They do a lot of work in the hardware space, and they found the initial S0 vulnerabilities, so they know what they're doing. They were hired to look at S2. One of the findings, up there in grey, it's highly, well, essentially it says they found this downgrade attack. So a pen test report found this downgrade attack. It went in as a high severity issue. Not critical, but high severity. You've got to be local, you've got to have equipment. It's not particularly easy to exploit. But what Sigma Design said to SensePost was that the behaviour was by design. It was to support backwards compatibility. And what that did was it moved a high severity vulnerability down to informational. Now, I don't know about you, but a downgrade attack that completely undoes the security statements you make about your protocol, I mean, I could understand it maybe going down to a medium, but taking it all the way down to informational seems really quite dubious. So in conclusion, what should we take away from this? Backwards compatibility is really hard. Now, I'm sure some of you are aware of TLS downgrade attacks, going down to SSL v2 and being able to break the encryption. The way that's mitigated in SSL v3 TLS1 is you take a hash of the handshake and then send that after you've been paired. But both sides have got to be aware that that's happening. Otherwise it doesn't work. The problem is an S0 controller has absolutely no idea that S2 security exists. This is interesting. Vendors are they're happy to promote their products based on security risks that aren't particularly real. Now, I don't have that much home automation equipment, but I'm not bothered about the risk of someone putting a Dropbox in my garden or sitting in a car wearing a hoodie with a laptop, grabbing my Wi-Fi key or something like that. It's not a risk that I feel is genuine, but they're happy to say our product's better than the competitors because of that. But then when you report those vulnerabilities to them, they say they're not a problem. It's kind of like this balancing act where they're trying to say, yes, we've got the best security in the world, but then when you say, yes, we've broken that security, they just say, no, it's not a problem. Marketing's a mile from reality. We find with these closed systems, these kind of like ecosystems where you don't really get insight, there's quite often problems. You just have to start digging. I mean, this took us, half a day of looking at it, followed by a shower and having a bit of a think about it to find the downgrade. It was that simple. There was no work involved. You just have to remember, though, this attack is incredibly unlikely. I don't think anyone's going to see this. But the thing is we're getting more and more of these devices turn up. I don't know if any of you went to the industrial wireless talk yesterday. So that was talking about how these similar security is being used with similar fixed keys to exchange keys for sensing networks in industry, for even control networks. And the security is not that much better. And we are going to see people starting to attack these networks. You just have to look at things like Stuxnet, where people really, really do put a lot of effort into it. And vendors really need to improve sooner rather than later. They need to start thinking about how to fix these problems now. And that might involve making some decisions about taking away backwards compatibility and improving security. So that's the talk. Any questions?
So who wants to start with the first question?
The part you talked about introducing the V2 security, did that exclude the downgrade? So only V2 and remove the S0?
No, S0's always present. You can't. I don't think they're going to allow S0 to be removed because this backwards compatibility thing, they will place that above all others. I mean, Home C, you can turn it off. You can say, I don't want to support S0 anymore. But then S0's still better than no security. So the problem there is if you pair an S0 device into a network that doesn't support S0, it goes in with no security. You can just walk up to your house and unlock the door, which is obviously very bad.
So it didn't actually solve stuff, only introducing new devices that have S0 in it.
Yeah, pretty much.
Okay.
We have found other problems as well. It's not all quite as rosy. We managed to brick these and run the batteries out on these and things like that, but nothing major.
Okay. Thank you for nice talk, really. When you actually send the replay message, the controller is going to receive actually two messages at the same time.
So,
or did I miss something?
What we do is the controller isn't in the pairing mode when we first start it. So the node sends its info first,
okay,
and then we put the controller into pairing mode. Now the problem is you've got a bit of a race going on here.
Yeah.
The device will keep on sending out that node info every 2 seconds to start with, then every 4 seconds, and then every 8 seconds. It backs off. But if we don't get our node info first, then the attack won't succeed. So the script waits 2 seconds. So it receives it, waits 2 seconds, then resends it.
Okay, great. So basically your message will be the one that is going to first get to the controller. Okay.
That's the idea.
Okay, now it's much clearer.
Yeah.
Okay, thank you.
Other question?
Hi, I'm actually with Scilabs.
Oh, hi.
Nice to meet you. I wanted to speak, I guess, on a positive note.
Yeah.
I mean, my presence here is one of the things that we are doing better.
Yeah.
And I think, and thank you also for the talk. I think it's been very, very useful. I do want to highlight that balancing security and backwards compatibility is just, in general, a very hard problem to solve.
Yeah, it is, yeah.
And we're trying to struggle with how to best do this with Z-Wave.
Yeah.
Because there are thousands of S0 products out there. And
yeah, I agree. It's a really, really hard problem to solve. I mean, I sat down and I just couldn't think of a feasible way of doing it with the low UI that these devices have got. The thing that I found interesting was the disclosure I was talking about there and it not going swimmingly. It wasn't until, I'm sure you know Lars.
Yeah.
Lars got involved, and from that point onwards, it was clear we were speaking to someone who understood where we were coming from, and from that point onwards, everything flowed brilliantly. Yeah. But I think, there was a lot of initial issues there.
Well, we also now have a pcert process.
Yes.
So
which makes things,
all notifications come in through a known flow, and
I'm thinking of testing that in the next few days.
But I just want to say we're aware of this, we're working on it, and thanks.
Cool. Thanks for your comments. There's one right at the back as well.
Which one?
Well, that was less uncomfortable than it could have been. I I remember I did the demo of this, and I noticed the people in the audience were covering up their name badges, and then when they uncovered them, they all worked for Yale, which is quite awkward. Sorry.
Yeah, just wanted to say thanks for standing up to John McAfee.
So if you want to hear about McAfee, is that how you say it? McAfee? I don't know. I don't know what I've been calling him. I've never really said it before, which is I've got to do a talk in an hour. Yeah, I'm doing a talk about BitFi. If you haven't heard about BitFi or BitFi, it's a hardware wallet that was called unhackable. It's the first time that someone's invited to me their house full of guns to go and hack something. Again, the technical side of it's not particularly complicated, but the disclosure process and some of the social media stuff's been quite interesting. So if you want to come and see that, I'll show you how the attacks work and show you some funny stuff, I hope. And I might be wearing my Pikachu suit.